Next gas law is Gay-Lussac's law. This one is dealing with pressures and temperatures. So, similar to before with that Charles law, I have two things that are going to be directly proportional. So the equation looks like this. Couldn't transfer that over directly, but you can see it now. So P1 over T1 equals P2 over T2. An example will look like this one: a gas cylinder, at room temperature 20 degrees Celsius is thrown into an incinerator where the temperature reaches 500 degrees Celsius. If the gas inside the container initially was at 760 torr, what pressure would it reach inside the incinerator? So I just need to collect what I know again. Doesn't matter what the pressure is, so I don't need to convert this. This one would be easy to convert because 760 is the same as 1 atmosphere, is the same as, right, that was one of our standard conditions. But I don't need that here, so I don't care. T1 is 20. 20 plus 273 is 293. I still have to make sure it's Kelvin every time, right? So you can't just keep the 20, you gotta add your 273 to it. P2 is what I don't know, but I'm assuming it's gonna be pretty big because I'm gonna heat up this temperature quite a bit. At 500 degrees Celsius is 793 Kelvin. So I'm at least doubling, if not tripling that temperature value. So it should make that torr quite a bit bigger. It'll be at least double that. So just got to solve for x here. Set it up. 760 divided by 293 equals x over 793. Again, I don't really use units in here all the time. It's probably a good idea to do so, but I know that the kelvins cancel out, so I don't need those, right? Whereas the torr answer, that's what my answer is going to be in. 760 times 793 divided by 290. Yeah, it's 293. So my new pressure is going to be 2056 plus a bunch of other numbers like a 0.92, whatever. I only get 2 sig figs in my answer because that's what my torr was up here, 2 sig figs. So I have to round it here anyway. It becomes 2100 torr. And again, that's more than double what it was initially. It's not quite triple, because triple would be bigger, because if it was just 700 torr tripled, it would be 2100. So you can kind of predict and see if your answer is reasonable if you think about the fact that this is directly proportional. But otherwise, just do the math and come up with an answer. At least know that the answer needs to be bigger than it was before. Because if you got a smaller answer here, if you only got like 125 torr, that's a problem, right? So make sure you kind of think about your answers. You can also predict what you think the answer might be, because it's a good way to check yourself. Otherwise, next example. A sample of helium gas has a pressure of 1.2 atmospheres at 22 degrees Celsius. At what temperature will the pressure reach 760 torr? So in this case, I have two pressures. P1 is 1.2 atmospheres. My temperature initial is 22. 273 onto that is 295 Kelvin, I believe. Now, just to know what numbers go together, just look for keywords. When I say at, that means those two numbers definitely go together. They're both ones, right? Whereas at what temperature will the pressure reach 760? Those are my new conditions, right? Some questions are harder than others to pick that out, but P2, T2. I know the second pressure, but I also should pay attention, right? Torr and ATM do not match, but so I need to change one of these to match the other. And typically in a problem, because I'm not trying to make you do a ton of extra work, I just want you to recognize that these have to match. There's usually one that's easier to convert than the other one. If you change this atmospheres into torr, that's fine. You can take 1.2 times 760 and figure out what that is. But 760 torr is equal to 1 atmosphere. So do the easy conversion if you can recognize it, right? I'll always give you one of those standard pressures so that you can convert it quickly. I might make it so that they don't match, but I'm typically going to give you one that's a standard condition so that you can change it quickly, right? So you should know that 760 is 1 automatically and not really have to do any math. Whereas if this was 787, you'd have to divide by 760 to figure out what atmosphere that is. So don't do that in that case. But it went from 1.2 to 1. That means that my pressure is decreasing slightly. So I would guess that my temperature is going to decrease slightly. So I'm solving for x here. 1 times 295 is just 295, so I'm not going to do that, divided by 1.2. I'm going to get an answer here of 245.83 repeating, right? The 3's repeat. But I need only 2 sig figs in this answer, so it's going to be 250 Kelvin. So again, recognize what's going on. It's nice to know that it's going to get smaller to begin with, because then you know that your answer is reasonable, right? So that's how you do Guy-Lussac's law. Next up is combined gas law.